Before we get into multiplying and dividing rational expressions, I want to remind us how to multiply and divide just plain old fractions, because the same steps are going to apply when we start talking about rational expressions. So let's kind of remember how fractions work. So first of all, the steps for multiplying fractions: you multiply the numerators and denominators and then simplify. So symbolically, if we had a over b times c over d, that would equal just a times c over b times d. However, when you're dealing with fractions, it's much easier if you cancel common factors before you do the multiplying. And that's exactly what we're going to see when we talk about rational expressions. Okay. Now, when it comes to dividing fractions, we need to convert it to multiplication. We technically don't know how to divide fractions, but we just learned how to multiply fractions. So what we do is we convert to multiplication. Now, you can't just willy-nilly change the division symbol to a multiplication symbol and expect the result to work out. It won't. So what we have to do is we have to compensate for that operation change. And the way we do that is we keep the first fraction the same, and we convert division to multiplication, but we multiply by the reciprocal of the second fraction. So remember, if we have reciprocals, so if I have the fraction a over b, the reciprocal is b over a. You just flip the fraction upside down, okay? So you keep the first fraction the same, you multiply by the reciprocal of the second fraction, and then you just follow the rules for multiplying. You multiply your numerators, then you multiply your denominators, and then you simplify, okay? So symbolically, that would be if we have a over b as our first fraction divided by c over d as our second fraction, that would become a over b times d over c. And then you multiply. However, just like with multiplication, it's easier if you divide out common factors before you do the multiplying across, okay? And again, we're going to see that same thing come up when we deal with multiplication and division of rational expressions. So let's practice one of each. And then in the next video, we'll talk about rational expressions. So for example 1, it says find each product or quotient. Well, I've got 15 over 16 times 24 over 35. So let's do some air quote factoring. I can think of 15 as 5 times 3. I can think of 24 as 8 times 3. That's my numerator. My denominator, I could think of 16 as 2 times 8. And I could think of 35 as 5 times 7. So I've sort of, in a sense, factored these. I've written each of these numbers as a factorization. And now I can like really clearly see things that are going to cancel. So 5 divided by 5, so there's a 5 in the numerator and a 5 in the denominator. If I divide those out, I just get 1. There's also, let's see, an 8 in the numerator and an 8. Well, let me do a different color. There. There's an 8 in the numerator and an 8 in the denominator. 8 divided by 8 is 1. So we've canceled 8s, we've canceled 5s. Now let's see what we have left. So in the numerator, I still have a 3 and a 3. In the denominator, I still have a 2 and a 7. Those factors don't have anything in common. There's no common factor I could divide out of those. All of those numbers are already prime. They don't have any other factors besides 1. So that's as good as it's going to get. Now I multiply across. So for my numerator, 3 times 3 is 9. And for my denominator, 2 times 7 is 14. And that is your final answer. So we can multiply across and then simplify, but I think it's easier if you do some simplifying first because, for example, just let's think about this for a moment. Let me grab my calculator. If we had multiplied first, I would have had 15 times 24, which is 360, divided by 16 times 35, which is 560. That's a little bit harder to simplify, don't you think? So in my mind, it's much easier if we simplify first and then, not simplify first, but like cancel out those common factors first and then multiply across, okay? So that's the method that we're also going to use when we deal with rational expressions. Okay, so part B, we have a division this time. So the very first thing we want to do is we want to rewrite this as multiplication. So 12 over 25 stays the same. But then I multiply by the reciprocal of the second fraction. So the reciprocal of 18/10 is 10/18. And now let's see if we can do some factoring, we'll say. So 12 I could write as 2 times 6. 10 I could write as 2 times 10, or 2 times 10, 2 times 5, good grief. 25 I could write as 5 times 5. 18 I could write as 3 times 6. And let's see if we have any common factors top to bottom that we could cancel out. So in the numerator, I see right off the bat a 6, and there's also a 6 in the denominator. So 6 divided by 6 is just 1. We also have, let's see, a 5 in the numerator and a 5 in the denominator. 5 divided by 5 is just 1. So now in the numerator, I have 2's. In the denominator, I have a 5 and a 3. I don't think anything else will cancel, so I'm left with 2 times 2 in the numerator, 5 times 3 in the denominator, and that's just going to equal 4/15. So that would be my final answer. So remember, when you're multiplying and dividing fractions, you can multiply across and then simplify. You can write as multiplication for division, multiply across and then simplify, but that can get kind of nasty. So simplify first. Think of factorizations of those numbers, divide out common factors, and then for the last step, multiply or divide. And I think it makes it quite a bit easier.